Why do planets just float in space and not come crashing down? Take Earth, for instance. Our planet weighs about 6 sextillion tons. That's a 6 with 21 zeros after it. So how can something this unimaginably heavy just hang there, steady as a marble in the sky, instead of falling? What invisible magic is keeping it up? Well, it's no magic at all. It's the combined work of three things: gravity, centrifugal force, and the vacuum of space. Together, they create a cosmic balancing act that keeps Earth and every planet in its place. Let's break it down. Gravity, the cosmic anchor. Gravity is one of the most fundamental forces of the universe. Without it, Earth couldn't possibly stay in orbit. It wouldn't even hold itself together. Legend has it, Newton saw an apple fall and thought, if this apple falls, maybe the moon is falling too, just in a different way. That's gravity. Every object with mass attracts every other object. The bigger the mass, the stronger the pull. And in our solar system, nothing is bigger or scarier than the sun. The sun holds 99.86% of the total mass of the solar system. That's like stuffing the weight of 330,000 Earths into one gigantic fireball. Its gravity is so strong that if something drifts too close, it's game over, instant barbecue. Yet somehow, Earth and its neighbors have orbited the sun for billions of years without being swallowed. Why? Because there's another force at play. Centrifugal force, the great escape. Earth whips around the sun at nearly 30 kilometers per second. That speed creates centrifugal force, an outward push, like the tug you feel when swinging a ball on a string. Here's the trick. Earth is constantly falling toward the sun, but it's moving sideways so fast that it keeps missing. That's what an orbit is, a never-ending fall that never hits the ground. Gravity pulls us in, centrifugal force flings us out, and the two forces lock into a perfect balance. It's cosmic tug-of-war that ends in a tie. The illusion of down. People often ask, if Earth is floating, why doesn't it fall down? But in space, there is no down. On Earth, gravity points toward the center, so down feels real. But in space, with no fixed frame of reference, up and down lose all meaning. Without that perspective, the idea of Earth falling just doesn't apply. It's not falling anywhere. It's orbiting, forever caught in its cosmic racetrack. The power of the vacuum. Now add in the third ingredient, the vacuum of space. Here on Earth, every movement faces resistance. Run into the wind, you feel it fight back. Throw a ball, it slows, stops, and drops. But in space, there's no air, no friction. Planets can spin, orbit, and race endlessly without losing speed. It's like the universe gave them an infinite freeway. No brakes, no stoplights. Right now, Earth is rocketing around the galaxy at 220 kilometers per second following the sun. That's 500,000 miles per hour. But we don't feel a thing, because everything on Earth, the air, the oceans, even you and me, are moving at the same speed. It's like riding a super smooth bullet train. You don't notice the motion until you look outside the window. Earth's spin, our daily show. Besides orbiting the sun, Earth also spins on its axis at about 465 meters per second, half the speed of a jetliner. This spin gives us day and night. It even makes Earth bulge slightly at the equator, turning our planet into a squashed sphere, more stress ball than perfect globe. That spin stabilizes our climate and magnetic field, making Earth comfortable for life. You could say, Earth comes with built-in climate control. Kepler's paths, not perfect circles. By the way, orbits aren't perfect circles. Kepler figured out they're ellipses, slightly stretched loops. Planets move faster when they're closer to the sun and slower when they're farther away. The balance still holds, it just breathes a little. Think of it like cruise control on a hilly road. The speed adjusts, the trip continues. Why astronauts float? Ever wonder why astronauts seem weightless? They're not outside gravity, they're inside it, falling with it. The International Space Station speeds around Earth at about 7.66 kilometers per second. It's in continuous free fall, always missing the ground. That's microgravity, not zero gravity, just a very long, very elegant fall. Basically, orbit is skydiving forever. Lagrange points, cosmic parking spots. Gravity can even create sweet spots where forces balance out, called Lagrange points. Space agencies park satellites there because fuel use is tiny and the view is fantastic. It's like finding the one table in a crowded cafe where the Wi-Fi is perfect and nobody bothers you. Will Earth always stay this way? So the big question, will this balance last forever? For billions of years, Earth's orbit has been stable. But what could break it? One possibility, a rogue star wandering into our solar system, disrupting gravity. Sounds terrifying, but the odds are practically zero. Stars are just too far apart. The other possibility? The sun itself. In about 5 billion years, the sun will swell into a red giant, a fireball more than 100 times its current size. It could swallow Mercury, Venus, and maybe Earth. Even if Earth survives, the sun's heat will boil away the oceans, strip the atmosphere, and roast the surface into bare rock. Not exactly a cozy retirement home. Humanity's cosmic future. But don't panic. Human civilization has only existed for a few thousand years, yet we already launch rockets, explore Mars, and send probes beyond the solar system. Give us 5 billion more years, and odds are we won't still be stuck on Earth. We might have colonies on Mars, space habitats around Jupiter, or even starships cruising to other stars. When the sun finally burns out, humanity may already be living light years away, under alien skies. Closing thought. So why don't planets fall? Because the universe set up a perfect game of balance. Gravity pulling in, motion pushing out, and the vacuum keeping everything smooth. Earth isn't magically floating. It's dancing, an endless waltz around the sun. And the fact that we can understand this dance, that's the first step to making sure we'll keep dancing long after Earth itself is gone.